Hey everyone, in this lecture we will discuss about pointers. Pointers is very fundamental and important concept in programming, but the beginner programmer find it difficult to understand the pointers. In order to understand this lecture, all you need to know just how to write a simple C program, how to declare a variable and how to apply arithmetic operations on those variables. To understand the pointers, we first need to understand how various data types or various variables stored in computer memory. When we talk about computer memory in the context of program execution, we mostly talk about random access memory or RAM. Let's say this is our RAM or memory. In the typical memory architecture of the memory, each byte of memory has an address. Let's say that this partition represents one byte of memory and it has an address. So let's keep it simple. Let's say that the byte in the deep down of a memory has an address 0. Let's say it has an address 0, and if we go on like, it will have an address 1, address 2 and something like that. Let's say for example, if we declare a variable a of type integer. So when this program executes, computer allocates some memory corresponding to this particular variable. So how much memory it will allocate depends upon the data type and also the compiler. So in general, integer is allocated 4 bytes of memory. Let's say it is allocated at, let's say that is 101. So 102, 103 and 104. This is particularly allocated to variable a. Similarly, likewise, for character, the computer allocates 1 byte of memory for character, and for float, computer allocates 4 bytes of memory. Actually, in general, under the hood, computer maintains a lookup table which stores this information. Let's say when I declare int a, it stores the memory for that variable. And in the lookup variable, it will store an information something like a, and it is of type int, and what is the starting address of that particular variable, which in our case will be 101. Let's say we declare another variable which is char, and it is equal to c. So for this variable, once again machine sees the declaration, so it looks for some free space. Let's say in this case the free space it founds at 209, and so the entry in the lookup table, it will be something like c char 209. Now if I update a variable, let's say I update it as a is equal to 5. So what computer will do with the help of the lookup table, it will go here and update the value 5. Actually the value will be written in binary, but for the sake of simplicity we are writing it in decimal form. Okay, and let's say I just do one more operation, which is an arithmetic operation. So in this case as well, first the computer will look into the lookup table for that particular variable, and it will go to the memory for that particular variable, and it will update or modify the value of that variable like this. All this stuff is very cool, but can we know the address of this variable in our program, or can we operate upon these memory addresses in our program? Well, we can do so in C and C++. So basically pointers are nothing but the pointers are basically variables that stores the address of another variable. Okay, let's say this is our memory and we have a variable p which stores the address of a. So as we can see that the value of p is 104 and it points to a. Now if I modify the value of p to 108, then it will start pointing to b. And as we can see that variable will also take some memory. Now let's discuss the syntax of pointer variables. Let's say we have defined declare a variable a, and if we want to declare a pointer, it will be declared something like a variable, but we just append the asterisk sign in the prefix of that variable. And if we want to populate that particular variable with the address, what we can simply do, we can just append the ampersand sign in the prefix of a, and then p will actually store the address of a. Okay, and it also points to A. So let's say I have A is equal to 5. So when I want to print P, what will be the value? The value will be simply 104, because the P is storing address of A and address of A is 104. Now if I want to print ampersand of A, as we know that ampersand of A also defines the address of A. So this is also equal to 104. And there is one more interesting thing. If we put asterisks in front of pointers, it gives us the value of the location that it points to. As we can see that P is pointing to A if it has value 104. So if I write asterisk P, then it will basically return 5, which is basically the value to which it points to. Fine. And what we can also do, we can also update the value. Let's say I just update the value as 8. So basically now if I print A, then the value will be 8. Because what I did, I just moved to that location and I just update the value whatsoever it was there, I just updated to 8. So this is all the basics of pointer. We will discuss some more advanced concepts in pointer in the upcoming lectures. So this is all about this lecture, guys. Thanks.
Hello everyone, we have discussed the concept of pointers and 1D arrays in our previous video. Now let us see how we can work with pointers in 2D arrays and in general multi-dimensional arrays. And we will also see how 2D arrays are organized in computer's memory. First, let us revise the 1D array and let's see how 1D array was stored in memory. So let's take a one-dimensional integer array of size 5. We know that it will be stored in memory like this. So memory is nothing but a large array of bytes. Let's say it has an index 0 in the leftmost position, and as we move right we have index 1, 2, 3 and so on. Let's say this block has an address 200, starting address 200, and if one block is representing 4 bytes of data, the next block will have address 204, then 208, then 212, 216 and so on. And let's say the first element of the array is stored here, then the next element will be stored here, third element will be stored here, fourth element will be stored here, and the last element will be stored here. Let us also give them some values like 3, 5, 1, 8 and 10. Now these 5 integer variables, which are consisting of one consecutive block of elements, is nothing but the memory allocated to this integer array. And we have seen this, that if we write a statement like this, int star p equal to a, where a is nothing but a pointer to the first element of the array. So p will point to the base address of the array. Now let's say if we want to print the value of p plus 2, this is nothing but pointer arithmetics. We know p is pointing to the base address, which in our case is 200, and the size of integer is 4 bytes. So it will add 2 into 4, that is 8 bytes, and it will move to 208 memory location. Now let's say if we want to print the value there, that is print star p plus 2, we know the value stored at address 208 is nothing but 1. So it will print the value 1 there. And in this case, instead of using p, we can also directly use a like this. So if I print a plus 2 instead of p plus 2, the result will still be same. And similarly, if I print the value at a plus 2 instead of p plus 2, the value still will remain the same. Also, if we write a statement like this, p equal to a, then this statement is valid because p is now pointing to the base address of the array. But if we want to write a statement like this, a equal to p, this will not be valid and will give a compilation error. So any integer pointer can point to the base address of the array, but the base address cannot be updated using the pointer. This was the one-dimensional array. Now let's see how the pointer arithmetic works in case of a two-dimensional array. So now let's start with two-dimensional arrays. And let's take an example. So let's take an integer array again, 2, 3. Now we are creating an array of array, and we are creating basically two one-dimensional array of 3 elements each. So basically we have b of 0 and b of 1, which are nothing but one-dimensional arrays of 3 elements each. That is 3 integers. Also, if b0 and b1 are one-dimensional array of 3 integers each, then size of b0 will be equal to size of b1 will be equal to nothing but 3, which is the number of elements, multiplied by size of integer, which is 4, equal to 12 bytes. So this will tell us that the memory allocation of b0 will require 12 bytes, and also the memory allocation of b1 will also require 12 bytes. Now let's try to draw the memory allocation of two-dimensional array. So let's say this is the memory block, or let's not write it here, and it is extending left and right, and let's say it is starting from address 400. Then we have a cut, and each block is again representing 4 bytes of memory, because 4 is the size of integer. Starting of this block will be address 412, starting of this block will be address 416, starting of this block will be address 420, and so on, it will continue. Now let's say if b of 0 is starting from this position, then we know that it will require 12 bytes of memory. So this complete memory allocation will be given to b0, and since the arrays is stored continuously in memory, so next 12 bytes will be given to b1. Also, let's try to fill in some values. So basically, we know all the blocks are integers. We can have values like 3, 5, 6, 1, 4. Now, we know that the name of the array returns the pointer to the first element of the array. This time, each element is not an integer. Instead, it is a one-dimensional array of 3 integers. So, if we will write the statement like this, int star p is equals to b, it will give a compilation error. Reason being, b will return pointer to the one-dimensional array and not an integer pointer. So basically it is not an integer pointer, instead it is a pointer to one-dimensional array. So type of pointer also matters in pointer arithmetic. So the right way to write this will be something like this, int star p and size 3 is equal to b. This will work because currently p is a pointer to a one-dimensional array of size 3. Now let's say if we try to execute some statements like this, that is if we are printing b, this will be same as printing %p of 0, that is the base address of b of 0, and we know the starting address of b of 0 is 400. So when the statement will execute in the program, it will return 400. Also, let's say if we try to print the value of this base address, it will be same as b of 0. Now we know that b of 0 is not an integer, instead it is a pointer variable pointing to the integer. So basically it will return an integer pointer, which can also be treated as %b of 00, that is base address of b of 0, and we know that base address of b of 0 is nothing but 400 again. So if you want to see b00, this block will be represented by b00. Now let's say if we try to apply some pointer arithmetics here and we try to print b plus 1. In this case, we know b is pointing to the address 400, but b plus 1 will not add 4. Instead, it will add size of one-dimensional array having 3 elements. So basically it will add 3 into 4 to it. So the output for this will be 412. And we know that b of 1 is also having the base address as 412. So it is nothing but this is same as n% b of 1. That is starting address of one-dimensional array b1, which is also equal to 412. Now let's say if we try to execute this statement, printing value at b plus 1. Now what will this give? This is nothing but same as b of 1, and we know b of 1 is also a pointer to an integer, and that will be nothing but the base address of b of 1, which is n% b of 1 of 0. We know b of 1 0 can also be marked here, that is starting integer of b1 array, and its address is 412. So this print statement will also return 412. Now let's do one complex print statement, and let's say if we want to print something like print star b plus 1 plus 2. Now let's see what will this return. Let's try to do it step by step. So b is a pointer to one-dimensional array, and b plus 1 we have seen is returning us b1, and star b plus 1, this is same as n% b10 or b of 1. So this can also be written as an integer pointer. Now we are adding 2 to this address, and we know that this is basically an integer pointer. So this will add 2 into 4, which is 8, to the starting address of b of 1, which will be 412 plus 8, which is nothing but 420. So this statement will return 420. Now let's do one more statement. Let's say if we write print statement like this, print of star b plus 1. Now let's see what we'll do. Now we know this is nothing but n% of b of 1 of 0, and we want to print the value here. So let's see, in our array the value present at b of 1 0 is nothing but 6. So this statement will return a value 6. Let's do one more print statement, which is something like this: print star b plus 1. Now we have removed the brackets from inside. We know b is a pointer to an integer array of size 3, and b of 0, this is nothing but b of 0, base address of b. This is an integer pointer. So if we are adding 1 to it, it will be nothing but n% of b of 0, 1. Now this star will evaluate its value. So this is the address of an integer, and b of 0, 1 in this array can be seen here. You know that if you want to find the value at this position, it is 8. So this statement will print the value 8. This is nothing but the second element of 1D array B0. Now we can see that for two-dimensional arrays, b of I, j can be written as star b of I plus j. Basically, base address of b of I, we are increasing it by j amount of times, and we are finding the value there, which is also equivalent to star b plus I plus j. The base address of the array b plus the integer I or the one-dimensional array, and plus j and the value present there. So this will return the value of b I, j. I recommend you guys to try all these print statements in the real code and see the output. And I hope this was helpful to you guys. See you in the next video. Thank you.